Hello and welcome to the second part of this tutorial series. In the first one, we used a tool called Instant Meshes to create a perfect mesh to create the disco ball effect. If you haven't seen that tutorial yet, maybe you should go check it out first because it's the basis for this video. And in this video, we're going to actually use that mesh that we already have with all the nice little squares and everything. And we're going to use animation nodes to put keycaps, like from your keyboard, onto all of these squares on the mesh to create a really interesting looking keycap artwork. I'm glad you're here. Let's jump into Blender and let's do this. Right, we're in Blender. This is where we left off at the end of the last tutorial. We made this cool looking disco ball skull, and we also made the bunny, right? Hold on a second, my skull needs to move to here. So we also made the disco ball bunny. Now in this video I'm just gonna use this bunny and I'm gonna recreate the keycap artwork. So instead of like little tiles or little squares of mirror, we're gonna place some keycaps. So we don't need any of these modifiers. We're just gonna need our bunny mesh that has this really nice topology, and it looks like this now. So if we want to place keycaps, first of all we need a keycap. Now you can download models. I'm just gonna create one real quick. So I'm gonna get a cube, maybe move it over here a little. Now how do we make a keycap? Go into edit mode. Let's do edge select. Let's select these edges on the outside here. And then Control B. Make it a little rounder. It doesn't have to be very high poly, but maybe like this. Okay. Then this edge on the bottom, we scale out a little. Maybe bring it up like this. Okay, cool. Now, I think I'm gonna simply remove that face at the bottom, and I'm gonna remove that face on the top because I want to create some edge loops here. So Control R, maybe like this. How many is that? On the bottom left, you can see number of cuts is 5. Okay, so we can do that over there as well. Simply hit 5, enter. Escape to place them in the middle. Now we have to fill in our top again, and this will make sense in a second, I hope, what I'm trying to do here. So I'm gonna create a face here. Then I select this last edge here, and I just hit F to create the top, fill in the top, because now, if we look at it from the front, and we enable what is it called, proportional editing, and we select this edge in the middle and we cheesy down a little like so, just a little, just to give it a little bit of a curve. Of course you can go and model something really complicated here. Usually they have a curve going the other way as well, but I just want one curve here just to be, you know, to make it look interesting. Now also maybe we want a little bevel around here, so like this. No, actually I want to select the edges here. So this going all the way here, and this one. Okay, and let's see if we can get a little bevel in here. Tiny bevel like this. Yeah, whatever, doesn't have to be perfect. So this is going to be my keycap. Let's move it to the scene collection, call it KeyCap. Okay, that's that. Now, how do we place this keycap onto all of these squares? We're gonna do that in animation nodes. So Let's create a new node tree. Let's go here, as always, switch on these options. And then let's think about this. So first of all, we need our bunny. So we need the mesh info. Nope. Let's do mesh input of the bunny. Cool. So here we get mesh, and here we get vertex locations, and we get polygon centers. And this is what we're gonna use to place the keycaps. We're only interested in the polygon centers, right? First of all, let me go here. Maybe get these out, create a new material, call it, I know, bunny black, and just give it a black dark texture like this. So this is going to be the inside, and then on top of this, we're gonna have our keycaps. Polygon centers. Cool. Now, we're gonna have to create an object instancer because we need a lot of those keycaps. So keycap, and we need how many instances? Just as many as the bunny has polygons. This many keycaps. Now we have a whole lot of keycaps in here, as you can see. And the viewport is quite slow now. Maybe I should switch this over to this view so that my recording doesn't stutter. Oh, well, it's gonna stutter anyway. Okay, now let's place those. So we need object transform output. These objects should be transformed. Why is this so slow now? To the polygon centers. So these are the locations. But of course, they're huge. So we have to scale our keycaps to something like 0.1. Now we have this. They're still big. So maybe 0.05. Still very big, but we'll play with that in just a second. Of course, the rotation is off, right? We want to rotate all of those keycaps to be along, like on the surface, which means they have to face like the normal. Where do we get normals from? Well, this mesh in object input node. If you hit N on your keyboard and you go to the node, you realize that this has way more outputs than are enabled by default. And in here we can enable polygon normals. Awesome. So if I want to plug that in here, of course that doesn't work because this is a vector, normal vector, pointing up from the face, but we need a rotation. So how do we do that? Well, there's a node. I'm just going to search for it, something with rotation. It is called direction to rotation. That's exactly what we want. C is up, perfect. Direction is a vector, which is our polygon normal. And then we have a guide, and we'll talk about that a little later. And then here we have Euler rotations, which we can plug in here. And then we have keycaps. What do we have here? Switch off wireframe. And they look like this. Looks like a big mess. Why? So first of all, let's look at our keycap model. Let's go into edit mode. Where is its origin? It's like here. So let's GC and bring it all up here so that the origin is down there. Okay. And then they're still way too big. So 0.02. Cool. 0.03. Okay, 0.025. Okay, now we have keycaps on the surface here. Now, before we go any further, let's do a little bit of a material so that we can actually look at something interesting looking here. Let's give our keycap a new material, call it KeyCap. Maybe switch over to shading. Yeah, why not? Zoom in. So these are all our keycaps. We have a principled BSDF, that is fine, but we want some random color variations, like we saw on that horse model of that horse piece of art there. So we need the object info because that gives us a random output, and we're gonna take a color ramp. Now let's create some beigey color like this, very bright. I don't know, maybe like this, maybe a little darker. Okay, then copy this over to this stop and make it really dark. More saturation, more brownish. Some of the older keyboards are very like, brown. So we can take random in here, color in here, and then we have some color variation for all of these keycaps. I think this looks fine. Awesome. Cool. Now, we do realize that we have one issue here. So if we zoom in here, we can see, well, most of them are aligned really nicely actually, but not all of them. So up here they sort of have a weird rotation going on. And then if we go up here, like on the ear, you can see, if I switch that over to this view, you can see the face, the underlying face is like this. It's like a square going this way, but our keycap is rotated. That's kind of weird. And we want to fix that. And that is where this guide comes in. So if you think about this, you have a face and then you have a normal, right, sticking out the center of the face. And no matter where this face is pointing, so where the normal is pointing, this is fine, this works great. But the normal vector has a rotation. And that rotation is sort of random. I mean, as you can see, it fits in most of the places, but not all of them. And this guide option here is where we can tell the direction to rotation node that creates this vector what the rotation of the normal should be. So we can give it like a tangent or a normal for this normal to tell the normal vector its rotation. And this is a bit tricky. So what do we actually want? Let's zoom in here and let's look at this. What do we want here? Oh, you know what? I think I'm going to zoom out and go shade smooth and enable auto smooth on the keycap. Right, so the underlying face is this face here. And the rotation of this normal vector is totally off. How do we fix this? Or how do we create this guide vector that we need to rotate the normal vector? Well, if you think about this face here, this quad, the underlying face, if we can somehow get like 2 vertices out of this, then we get our guide vector. And we have the rotation vector for like this vector, right? So this is the normal vector, and we can define this one, where should it point, so that the rotation of the normal vector is correct. We can get this one by just getting a vector from one point of a face to another point of a face. We can do that in animation nodes. And this is really where geometry nodes is way behind or far behind. I'm sure it will be there at some point in time, but right now, animation nodes does it all for us. So how do we do this? Well, the bunny mesh, this is what we have here. We have the polygon centers, we have the polygon normals, and if we select this and go back in here with N, we can also get the polygon indices. So this looks interesting. Let's put in a viewer node. Let's see what polygon indices is. And you can see, where can I put this? So we get a list. It's a list of polygon indices. So each entry in that list is another list. What does that mean? Our first polygon, our first quad, has 4 vertices. It's a quad. And the first vertex is the first vertex in our list of vertices. So index 0. And then it goes to index 1, index 2, index 3. The second polygon in our bunny mesh goes 0, 4, 5, 1. So it's sharing basically this edge from 0 to 1, right? That's just the next. So this is the first quad, and then the next quad is right next to it. 0, 4, 5, 1. And this one goes 0, 1, 2, 3. So this gives us the indices of our vertex locations, and this is how polygons are made up. Okay, this is good to know. So we have vertex locations, and thus vertex location 0 would be the first point of this polygon. This is very complicated to explain, but I'm sure you get it. So really what we want, we know we might have triangles, but we mostly have quads. I don't know if we have n-gons in there, not sure, but we always have at least 2. So what if we take the first one and the second one, which gives us a line, which gives us a vector, which is going to be that guide vector. Let's do that. We're gonna need a loop for that. So let's create a subprogram loop. We plug in, we can see here the type, a polygon indices list. This is what we have to plug in here. Polygon indices list, right there. And we select this W, invoke node, put that down here, and we can plug our polygon indices list in here. So this is going to be our loop. Maybe I have to get some more space here. Put this over there. Okay, so in here we get polygon indices. So one entry, first entry 0, 1, 2, 3, which is another list. And from a list we can get an element. Get element from this list, first element, and then Shift D, same list, get index 1. So this one, this output here would be 0, this output here would be 1. And in the second iteration for the next polygon, this would be 0 and this would be 4. But we don't have any positions in 3D space yet, so we need those vertex locations. We have to put those into our loop somehow, and we're just going to plug them in, not as an iterator, but just as a parameter. So we have, what is it, a vector list, which is this, and we can put our vertex locations into our loop, so we can use it in here, because now we need element, what is it? Let's look at line number 3, or the third line with index number 2. So 6, so this will be 6. We take the 6th element from this list, and then again from this list, we take the, what is it? 3rd element. So now we have 2 positions in 3D space. And when we look at this underlying face here again, maybe it's this one, it's the first one, and this one is the second one. So now we can create a vector going from here to here, simply by doing a vector math. We subtract this one from that one, or the other way around, doesn't matter. And now we have a vector. Can we somehow visualize this? Yes, because there is a loop viewer node, which is very handy. And let's just check this out. Let's look at this output first. Create a new output, place it over here, make it a little bigger, and then execute our node tree, execute. And we get this output. And if we zoom in here, you can see, so the output here is 006051, should be 006051. Works. This would be the other output, second one, which would be this column, 14384, 14384. Exactly. Now here we're getting the vector of this index. Here we're getting this vector. And then by subtracting the one from the other, we get a new vector, which is going to be our guide vector, and we're done. Cool. So now we have a vector for each polygon on the bunny, going from the first vertex of the polygon to the second vertex of the polygon, and this also works for, of course, for triangles. Cool. Good to know. Now we have a vector output. What can we do with this? Well, this is going to be the output of our loop. So we go to this node, we create a new generator. Output is a vector list, plug that in there, and then our invoke program outputs a vector list. This is going to be our guide vector, but one more thing, we're gonna plug in a vector math again in here, and we're gonna set this to normalize length 1, which just takes care of the fact that this vector might be super long or super tiny, but the guide vector should be of size 1. I don't know if it's necessary, but let's do it anyway. So now we have guide vectors coming out of our list, plug those in here, and look at that. All of the keycaps are now aligned perfectly with the topology that we create, we get from the instant meshes tool. So up here on the ears, you can see this is perfect, 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 perfect. Now, one more thing that we might want to think about here. Where can we see this effect? So back here, this is a good example. Where are we? Oh, here on the butt. So let's switch off this for a second. Here you can see, oh, those are triangles. It doesn't matter, but they're tiny. Of course, the instant meshes does its best to create nice squares and same size squares, but it's not always possible. So here we get smaller areas or smaller faces. And of course, with the smaller faces and all keycaps being the same size, we get this overlay. Now, one thing we can do about this is to actually scale our keycaps. So let's say we're not using like all the same keyboard models for creating this piece of art. Maybe we have keyboards with smaller keys. How about we just scale these keycaps based on the size of the polygon of the bunny? How can we do that? Well, first of all, we're already scaling our keycaps to a factor of 0.03. But this node, cool node that it is, let me just close this. Let's go back to the node here. It also gives us the local polygon areas. So if we enable this output, now we get local polygon areas. What does that look like? Let's plug it into a viewer. It shows us the area of the polygon, and they're really tiny, 0.00563. Okay, so this is a list of just the area of the polygon. And how about we use that to influence this scale over here? So how do we do that? We're gonna need a number math node. We're gonna take our 0.003. We're gonna multiply it by this polygon size and plug that into our scale. Of course, that doesn't work because this is just a double. And here we need a vector, so we're gonna go combine, scale, plug this in here like that. And then what do we have? We have nothing because this now is probably super tiny. Yup, because those values are already super tiny, as you can see here. So actually we need to multiply this by something bigger now. I can just scroll and make it match here. Maybe we should look here. You can see this polygon is really big, and then these are smaller. So it looks like this now. Okay, with that set up, we can see that we get really tiny ones here for the tiny areas, and then we get like regular ones here. And then there might be some areas with some really huge ones. So we really don't want the huge ones, and we really don't want these tiny ones. I mean, a little bit of variation like these ones, those are okay, right? Because maybe they come from a smaller keyboard. But those super tiny ones, they are not good. We don't want those. So how can we fix that? I think for those really tiny ones, we just want to make them disappear. How can we do that? Maybe we just need some sort of if. So if this area is below a certain value, then we just want to scale it to 0, effectively making them disappear. How can we do that? We could do, I think we're gonna need a loop. So okay, create a loop. We're gonna plug in a list of polygon areas. So we're gonna need a float list that we can iterate through. If we create invoke node, we can plug that in there. Okay, so this is this subprogram. And then inside of this list, we can do some Boolean thing here. Like for example, what if we compare the area? No, we want a Boolean number compare numbers. What if it's smaller than, if it's less than a certain, this is less than a certain value, like 0.02, I don't know. Let's see. Then if that is true, we need a Boolean switch. We can switch to Boolean. If it's true, then we want 0. Cool. If it's false, we want the original size. So here we have either 0 or something greater than this value. And this is the output. So the loop creates an output. Again, it's a float list. And now we're piping this, whoopsie, we're piping this in here. So every value from our mesh first goes through this loop with this if in it. And then you can see this disappears. If I mute this node, I can't mute this node. Cool. If I plug this in here, we get those tiny ones. And if I plug that in, the tiny ones are gone. We still have some size variation like these here, but those really, really tiny ones, they make no sense because there's no keyboard that small. Now we can also do the same thing with these really big ones here. So we could sort of clamp down the maximum, and that's really easy to do. We can do that maybe down back here. So let's create a reroute node so we can plug in something in here. We just need a number math set to, what do we want? We want the smaller one, right? So min, where is it? Minimum, where is it? Maximum? Oh, minimum, wow. Okay, plug that in here. We want the smaller one. This, I don't know what the size should be. Let's just play with this a little. So we're capping off those super big ones to be like this big. What is it? 0.03. Okay, so we remove the super tiny one. There's another tiny one right there. Maybe we have to play with this 2.5. Yep, that gets rid of this one. So how big is this guy? 2.1. Let's just do 2.5. So here we have a naked spot. That's okay. No keycap can fit this face. If you want to fix issues like these, then you really have to go in manually and change the topology of your bunny mesh. But I think, I mean, for an automated process, the instant meshes tool is really awesome, and it gives us this. I mean, this is amazing. I think this looks really cool. We have keycaps, we have different sizes, we have different colors, we have them aligned to the actual square or polygon that we have. And I think this looks really amazing. And I mean, the node tree is really not complicated. We have 2 loops, one for capping the, or cutting away, masking away the really tiny ones. And then this loop for just aligning our guide vectors so that the normal has a rotation. That's that. It's not very difficult. Now this video is already quite long, but maybe we want to play around a little more with like putting letters on here so that it actually looks like a keycap, right? So the thing that I did for that was the following. Let me just show you. Let's go to this guy. Let's go to UV editing, and I'm gonna load in an image, this one, and I'll explain why I did it that way. So let's select this, go, why don't I have overlays? Okay, so first we need to UV unwrap this keycap. How do we do that? Well, I think I'm just gonna go maybe in edge mode, select. Ooh, this is tiny stuff here. Select this edge. Over here we're gonna select this edge, and then back here we're gonna select this edge. Yep. Okay, we're gonna mark those as seams. Yep. And also maybe, I don't know, maybe down here I'm gonna select this one and those and mark those as seams as well. So now I can go AU unwrap. What does that look like? Like this. Okay, awesome. So let's get this out of the way by just scaling it really tiny and moving it to a place where it doesn't matter, because we're only interested in this one. Scale X, make it look square again. You can of course do this much better, but I just want to get this done quick and dirty. Place it here, and this is like this. Make sure that it's in the center, looks good. This is going to be the letter for this keycap. So over here, keycap, we have to get in our image texture, image, take the logo letters PNG, because that's what we just UV unwrapped, and we're gonna mix that with our color mix RGB. Use this as the factor between black and our keycap beige. So now we have a black C on here, right? And now let me explain quickly why I did it this way. So first of all, I tried to create several UV maps, but then I couldn't figure out how to assign random UV maps in the shaders. I don't think that works unless there is some trick. I don't know. Then I tried to assign those UV maps using animation nodes, and that kind of works, but it really didn't work at all. It sort of messed up the entire UV maps, and I just gave up. And then I just thought, you know what, it's quite easy. If I create my letters and I just used CRISP, of course you can use the entire alphabet and do all that, but I just used my CRISP logo sort of thing. If you go this way and you have one UV map configured, like for this C now, we can go to the shader editor. We can go Control T to get a mapping node in here. And now if I move the Y location of my UV map, I get all the different letters, right? So CHR. Now how does that work? If we go to 0, we get the C. And if we go to 1, we get another C. So basically, although here it says meters, right? It's sort of like percentages. So this up here would be 0, and this down here is 1. And since this is tiled, if we set it to 1, you have to imagine the C down here, and then another H down here. So really all we have to do now in the shader editor with this setup is move this Y axis here based on our random. How do we do that? So first of all, we create a vector. So because we need a vector here for the location, we create a converter combine XYZ, gives us a vector that we can plug in there. Okay, nothing changed. Now we need a random, plug this random into our Y. And then we get this, which of course is not good, because you can see here it's sort of, the random is a value between 0 and 1, so any floating point value. We sort of have to cap it to 0 and then a sixth and another sixth. So let me show you. We can use a map range node, which doesn't do anything by default because it just maps from 0 to 1 to 0 to 1, but it has a cool mode which is the stepped linear mode. And we can map values between 0 and 1 to values between 0 and 1 in 6 steps, which is exactly what we have because we have 6 letters. And now if we look over here, look at that. Each keycap has a letter perfectly mapped to it. It's all done in the shader. And it's possible because of this. Right, we're only moving our UV map down a sixth of the way with some random. Now let's go back to shading and let's look at this a little bit closer, because there is one issue left, and that is, you can see here. Just look at the P letters here. Since we're always using this random value here, the random for the color is the same as the random for the selection of which letter to show, and the P's all have the same color now, and the H's all have the same color, and the C's all have the same color. No, we don't want this. We want a different random number for the letter selection. We could, for example, use a white noise texture, plug that in here, and set it to 4D. So we plug that into there, which is the 4th dimension, which would be the seed for a random value. And now just by doing that, although we're using the same random number, let's look at P's again. Here we get a dark P, here we get a lighter P. We just get different random seed for our letter selector. And if you're not happy with this, you can actually play with this vector now, and you can see we can randomize everything now. So this is how you get a different random seed in a shader, a very simple shader. And this is our result of the keycaps. Let me just go back here. Let me maximize this so you can look at the node setup for the animation nodes, node tree. And we're done. We created some cool looking keycap artwork. So this is how you replicate that Houdini tutorial in Blender with just this very awesome remesher called Instant Meshes that I showed in the previous tutorial, where you can get it and how to use it. And we used some animation nodes to do some cool things with placing, first of all, instancing our keycaps and then placing them in the right locations, facing outwards along the normal, and even rotating them so that they actually fit on our mesh, so that they're aligned with the mesh. And of course, you throw in some lights, you render this out, and you get some cool looking animations. I hope you enjoyed these 2 tutorials. I hope you learned something new. If you did, please give the videos a thumbs up. Please also comment down below. That lets YouTube know that this was a cool video and more people should see it. I know most of my viewers are not subscribed to my channel. That's okay, but maybe you want to subscribe. I appreciate it. Also, you can enable that little bell icon so that you get notified when I publish a new video. You can follow me on Instagram and Twitter, and you can get the blend files that we created in these tutorials over at patreon.com/ChrisP. Thanks for watching. Chris P out.